Hi everybody, welcome to your first Vodcast. In this session, we're going to look at our introduction to ecology, to how organisms interact with one another, and sprinkle in there a little bit of the scientific method, which I know you guys have had some experience with in the past. So let's just jump right in. Okay, so we are going to be looking at a whole lot of organisms, the relationships of those organisms to one another over the course of this unit, and then build ourselves into looking at how populations work together. So here we go. So ecology. Here's our working definition of ecology. It's the study of the living and the non-living parts of the environment and how they affect the organisms that are there. So not only are organisms affected by things that are living, they're affected by things that are non-living as well. So this is kind of a big deal, that it's not just living, but it's the non-living parts too. So these interactions happen in a couple of ways, but the biggest part to really understand about all of this is that the interactions really revolve around the acquisition of energy. This is a huge, huge deal, okay? Because without energy, life can't exist. So energy is a vital, vital component. Or I should say, getting energy is a vital component to all living things. And with that, we can actually track how energy transfers from one organism to the next using something called a food chain. And that food chain shows how the energy moves from the first organism that acquires it to the next, to the next, to the next. So here's an example of a food chain, okay? All food chains in all life, all of our energy begins here with the sunshine. Okay, and that is our ultimate source of energy. So the sun comes in, passes its energy down to our producers. Okay, these are the organisms that are capable of taking the sunlight and converting it into a chemical form of energy. That energy then gets passed on to the first set of consumers that eat the producers, and so on. Then the second set of consumers that eat those, and then the fish that eats the larva, that fish gets that energy. The bigger fish eats the little fish, and the big fish gets the energy from the little fish. And then next thing you know, okay, you're catching your dinner. Okay, notice though the arrow here. This is a really big deal. Okay, the size of the arrow. Can you tell what's happening as it goes through? Right, it's shrinking. Okay, so we're going to talk a little bit about why that is. And one of the things that is sort of missing from all of this is the role of a group of organisms known as decomposers. These guys are vital, okay? They are vital because they are the ones that are going to recycle all of these guys that die, okay? So our decomposers are important for returning the nutrients back to the beginning of the cycle. So they play a really, really important role. So this decay process, it's fueled by that. So they get their energy from breaking down things that have died, and then in turn pass that nutrients on to the next generation. So our little food chain that we showed is one single example of what we call a community. And we're going to come back to communities in this unit. But a community is a group of organisms, all the different species, all the different types that live in one area. You don't just have one type. And communities are so important because they interact. And we all know that one organism doesn't only eat one particular thing all the time. So they can eat different things. So when we take all of the interactions and all of the food chains that exist in a community and we join them together, we don't get this lovely linear straight line. We get a web. And as you can see from this web, we have a lot of organisms, from starting with, again, those producers here. Where are my plants? These are the guys that come in that get that energy from the sun. And then you can see the energy from these plants is passed on to the grasshopper. It's passed on to the rabbit. Okay? The energy from the grasshopper and the rabbit are passed on to different organisms. You just follow the arrow. So the direction of the arrow is important because the direction shows which way the energy is going, not what eats what. So, this isn't saying that, hey, grass eats the rabbit. No, the arrow is all about the energy. The energy is moved from the plant to the bunny rabbit. So basics. basics about life here. Again, we talk about that energy. Everything needs energy. Okay, really, really key. So this idea of the energy, okay, coming from there, sorry about my arrows, okay, that the consumer energy we get in the form of food, which then comes in the form of chemical energy, which is pretty important since the energy that hits our planet hits in the form of light. So we have to be able to move that. And we digest our food in a process that releases this chemical energy known as cellular respiration. So we'll get to the basics of cellular respiration here as we work through and how that works. Our producers, they convert energy because they take sunlight, okay, and they convert it. They take this light energy, and by taking the light energy, convert it over into chemical energy. Okay, and we're going to come back to how that happens in the upcoming, in our upcoming podcasts. Now here's the thing, if I go back to remember when we talked about why were the arrows shrinking from the sun as we went through the food chain, and that's because energy isn't always 100%, it's not 100% transferred. Energy gets lost from a food web. It gets lost in the form of heat. And as I, eat my lunch, the energy that was stored in there doesn't all come to me. Okay, I only get a very, very small amount of the actual energy. So that way, that what's in me from my lunch is only a certain fraction of that. If something comes by and eats me, it's gaining an even smaller fraction of what I had for my lunch. And as we go through, that energy becomes less and less and less available. So a community can only sustain top level, food chain eaters, okay, can't sustain too many of them. That's why you don't find, huge amounts of your top of the food chain in terms of numbers. You find tons of plants and tons of first degree consumers, but what we don't find are tons of the top level consumers because there isn't that much energy available. I like to think of it like a car, okay? When you put your gas in, right, it talks about, miles per gallon, right? And a more efficient car can get more miles per gallon, okay? So it can utilize more of what's available energy. A gallon of gas is a gallon of gas. But if I put that gallon of gas, in a huge, crazy big truck Escalade or, SUV, or I put that gallon of gas in a Prius, okay? Same gallon of gas, same amount of energy, the Prius is going to get more out of that gas because it's able to utilize more of that energy, whereas a lot of the energy stored in that gasoline is going to be used up in, the heaviness, movement, wind resistance, okay, movement of the motor and the engine, because even the Prius can't use all of that energy because motors move. Friction causes heat. That's why the top of your hood gets hot. So that's one way to always think about the fact that no energy transfer is 100% efficient. So here's what we mean by that. You've got the energy coming in from the sun. Notice again that size of that arrow. The producers take it, okay? They take that energy, feed themselves, they feed other organisms. Energy gets passed on to the consumers that eat the producers, and energy gets passed out as heat, mostly. However, nutrients, though, are recycled, okay? And they are recycled, thankfully, due to decomposers. So this cycling action is because of the decomposers. So that's what it is. The nutrient cycling comes from the decomposers. They take the stuff that's died, they take their nutrients, they recycle it. So big thing, big takeaway message here. You cannot recycle energy. Energy is a one-way path. Notice, we start from the sun, we go down. Linear, okay? Energy can leave in terms of like exits, but what you can't do is it can't come back. You can't recycle it. However, the matter, the stuff that makes up who we are, that can be recycled, okay? So we can recycle matter, but we can't recycle energy. So we always have to have energy coming in from an outside source, aka the sun. So how do we make new tissue? Here's where we get into a little chemistry. There's a hierarchy, okay? How does that work? We start with the atom. Atom is the basic form of matter, and you guys learned a little bit about the atom in physical science. Okay, made up of three things: protons, neutrons, electrons. So if I put a bunch of atoms together that are the same, They're just not hooked. I got a pile of them. That's an element, a single type of atom. If I hook a bunch of elements together, chemically bind them together, I get what's called a molecule. And if I take that molecule and maybe take a couple molecules and chemically bind them together, that's a compound. And that's the key thing. These are chemically combined together, okay, chemically. So those atoms are chemically bonded. There are about 30 elements that are used in the makeup of all organisms, but there are 6 biggies, and these are the 6 biggies you need to know. These are the 6 main elements of living things. Carbon is the big one. We are carbon-based. Hydrogen, oxygen, nitrogen, phosphorus, and sulfur. I like to think of them as CHNOPS. CHNOPS. Okay? So carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. 6 main elements that make us up. Then we have about another 24 elements of the periodic table that exist in us, but not nearly to the same abundance, okay? Way low. These are the majority of what we are, those 6 elements. So inorganic versus organic molecules. This is something that's going to be really important over the course of the years to understand that distinctive difference. If I talk about an inorganic compound, it means that the compound has less than 2 carbon atoms. For example, carbon dioxide. It only has 1. That's why there's no number next to the C. That's implied that it has 1 carbon atom. So it's inorganic. Okay? An organic compound has more than 2. So, for example, here's an organic compound. It has 6 carbon atoms, and that is actually glucose, one of the most important carbohydrates that we use. This is the main source of energy for our cells. This is what we break down in boatload amounts daily. And so to wrap things up, all of these interactions are going to take place whether we want them to happen or not. And they take place in this very, I guess in the grand scheme of things, very small location known as the biosphere. This is where life exists. And one organism is not independent of any other. We are all influenced, we are all affected by the organisms that we live around and among. And without each other, okay, we can't keep stability in life. And so from this sort of big picture idea and where we've started, we are going to build on that. We're going to do stuff in the lab that's going to explore some of these ideas. So this is just to give you an intro to it. I want you guys to kind of make note of some of the important terms that we've used. We're going to play around with this stuff, and don't forget to do your whisk form. Okay, that's something that's going to become habit as we go through this. It's located down there, right below us, and fill that out so that I know that you've taken this. So that you come with your notes. Come with your questions. That's a big piece, is what questions do you have from this that we can work together to find answers for. And we're going to get started. So I'm super psyched about this year and can't wait to really get into the nitty-gritty with you guys. So take care, and we'll see you guys later.